Let's analyze this function here by finding the critical numbers on the following interval. Notice this is a function from your trigonometry experience, and if you remember your identities, this is not a problem, right? However, if you don't remember your identities, then of course go ahead and relearn your trig identities. The first thing we're going to do is take advantage of the language of trigonometry. We want to rewrite f of x. Let's rewrite f of x to be this. That's just simply 1/2 sine of 2x. And that is still on the same interval. Notice all I did was trigonometry there. I haven't done any calculus. If you are struggling with that, just recall that 2 sine of an angle times cosine of an angle is the sine of a double angle, or 2x. So if you look at this very, very carefully, if you balance this equation, you should see this new trig identity right there. Now we're ready to differentiate. So when you differentiate this, you're going to need the chain rule. So derivative of the outside function evaluated at the inside function times the derivative of the inside function, which is just 2. So our derivative looks like this. Now the denominator here is 1, so we don't need to worry about any type 2 critical numbers. Let's concentrate on type 1 critical numbers. Type 1 critical numbers says what happens when the first derivative is equal to 0, and then we're going to solve for our c values. So a cosine of an angle gets you the trig value of 0. So working backwards here, we know that 2c has to equal pi over 2 plus every rotation of pi radians. We'll go ahead and find common denominator. Oh, actually, no, I won't. Let's solve for c. Let's multiply both sides by 2. And then do some algebra. So it's every odd multiple of pi over 4. Now remember what our k values from trigonometry. K is in the set of integers. So the first integer that will work looks like it's going to be k equals -2. So with k equals -2, we're going to have a critical number. And that critical number is -3 pi over 4. And when you do the next integer, which is k equals -1, we get c sub 2, which is equal to -pi over 4. And so on and so forth. So you just keep counting here like you do in a trigonometry course, and you'll be all right. Or an algebra course. You had to count in algebra for sure. So yeah, we just count. No problem. Most of calculus is just algebra. So if you master your algebra, you could learn a lot of calculus. C6. And we just count and count. And I think the last one is going to be the integer k equals 5. And that will give us our last critical number. Our last type 1 critical number is 11 pi over 4. So in this case, we have 8 critical numbers of this function. Now, does this match your pre-calculus experience? Does this match your intuition? Hopefully it does, because remember this function, another name for this function is simply this sinusoidal wave, 1/2 times the sine of 2x. And we already know the period for this function. The period for this function is actually pi. So we could actually draw lots of these. I'm going to use NTS here for not to scale. Now remember, like I said, if you know a lot of trig and know a lot of algebra, you could know a lot of calculus. So notice from your graphing experience, this is the amplitude of 1/2. So I'm going to put it right here. And I already wrote NTS, which means not to scale. This is a sinusoidal wave with the period of pi. So I'm just going to cut these into fourths so that we could draw our sinusoidal waves. I'm going to draw this 4 times because this period is going to repeat 4 times. And notice this is all just from your trigonometry experience. And this will all work out beautifully, right? Whoops. And now, are you convinced that you will have this many critical numbers for your oscillating function? Hopefully you are convinced. This keeps on going forever, but notice you're only looking at an interval from -pi to 3 pi, right there to here, -pi to 3 pi. And so that kind of gives you this intuition that what you're doing with the derivative here matches with your overall pre-calculus experience. Now, what is an answer, or what is a solution to the problem? Well, you need to show the first derivative, obviously. You're not required to graph this, but these graphs, I mean, you should have them. You should have them as general knowledge, as graphing and the subject of algebra and trigonometry could give you that much better of an experience in calculus.